Classify triangle ABC by its sides, then determine whether it is a right triangle. Okay, well, in the coordinate grid, we need to use the distance formula to find the length of each of the sides and to see if any of them are congruent. And to get the distance formula, we need to find the square root of the sum of change in x squared plus change in y squared. So we could use that to compare the lengths to determine whether the triangle is scalene, isosceles, or equilateral. Now, to determine that if it's a right triangle, one way to do it is to use slope. And to use slope, we need to know that it's a change in y over change in x. A lot of times they use the letter m for it. Okay, so we're going to need that. And if you notice that in both equations, we need the change in x and the change in y. And to make sure we calculate them correctly, I have one way of doing it. So let's get started. Triangle has three sides. Well, one of the sides is AB. So I have A, which is negative 2 comma 3, and I have B, which is 0 comma negative 3. And I want to calculate the change in y and the change in x. And this is the way I like to do it. What I'll do is I'll take the y component of A and go to the y component of B in this direction, and that's going to be my change in y. If I'm going from 3 to negative 3, I have to subtract 6, so that is my change in y. My change in x, well, that's the other two parts. And if I'm going from negative 2 to 0, I actually have to add 2. So I got my change in y and my change in x. Let's do the slope. So the slope of this guy, AB, is negative 6 over 2, which reduces to negative 3 over 1, or just negative 3. Okay, let's find the distance between these 2 points. So the distance of AB is equal to the square root of negative 6 squared plus 2 squared. Well, this is equal to 36 plus 4, which is equal to the square root of 40. Okay, so I got that one done. Let's go to BC. So B, again, I'm going to use 0, negative 3, going to C, which is 3, negative 2. And let's find the change in y. And my change in y here from negative 3 to negative 2 is plus 1. And my change in x here, going from 0 to 3, is 3. So my slope of BC is equal to 1 over 3. And we're done with that. Let's check the distance of this guy. And again, it's the change in x squared plus the change in y squared. So, well, my change in x here is 3 squared plus my change in y squared, which is 1 squared, which is equal to 9 plus 1, which is equal to the square root of 10. Okay, one more length to check. And let's go from C, 3, negative 2, to A, which is negative 2 comma 3. And my change in y here is equal to, well, I got to add, what do I have to add to negative 2 to get to 3? I have to add 5. And now my change in x here is, well, I have to go from 3 to negative 2. Well, here I have to subtract 5. Okay, so my slope of CA here, going from C to A, is 5 over negative 5, which is equal to negative 1. Okay, now let's do the distance. So my distance, let me just move this up a little bit, okay? My distance of CA is, well, my change in x here is negative 5 squared plus my change in y, which is 5 squared. So this becomes, well, a negative number squared becomes positive, it becomes 25 plus 5 squared is also 25. And so here, the square root of 50 is the length of my segment CA. Okay, so looking at just the lengths, right? I have one that's square root of 40, another one that's square root of 10, and the third side, which is square root of 50. So taking these three lengths, they're all different. So this triangle, triangle ABC, is scalene. All right. Now, let's look at the slopes. Okay, if it's a right triangle, we need to know that the slopes are negative reciprocals. So we have to check if their slopes multiply to 1. So let's check. Look at MA, AB times, let's say, MBC, and see what it equals. Well, negative 3 times 1/3 is equal to negative 3 over 3, which is equal to negative 1. Oh, we're done. I know that AB is perpendicular to BC because their slopes are negative reciprocals. And perpendicular lines form right angles. So triangle ABC is a right scalene triangle. And we're done.